Certain rules apply to polyatomic ions when they're still ions, but we have to change the name based off of what's happening to them. We've talked about the rules of the oxyanions, where oxygens are being added or taken away, and how either a prefix or the ending changes. Now, what if there's a hydrogen? So most of the time, when there's a hydrogen in front of a nonmetal, we think acid. Very, very common one is HCl. We know this is called hydrochloric acid. However, this is the case when it's a compound. That means if I put HCl in water, I will produce hydrogen and chlorine. That is the definition of an acid. When you have hydrogen in front of a nonmetal, but it's a charged substance, it is not a compound, it is an ion. Then you have to name it in a covalent type of way of naming how many hydrogens you have with the polyatomic ion. For example, let's look at carbonate. CO3, 2-. This is carbonate. Now, if I add a hydrogen, hydrogen is +1. If I add a hydrogen to CO3, +1 and a -2 gives me still -1. So I am not an acid. So now I have to say, all right, I am hydrogen carbonate. Now, if I add 2 hydrogens, that's a +2 now, I no longer have a charge. Now I have an acid, and I would write carbonic acid. Sometimes you can have multiple hydrogens added. Let's look at another example. For example, phosphate is PO4, 3-. If I added a hydrogen, that's a +1, I have PO4, 2-. I would say hydrogen phosphate. Now, if I add 2 hydrogens, PO4, 3- was my base, 2 hydrogens, that still gives me a -1. Now I have to indicate that. I can't just write hydrogen phosphate because it's not just 1 hydrogen, it's 2. So I write the prefix di, meaning 2, dihydrogen phosphate. Now if I add 3 hydrogens, I have a neutral compound and I have an acid, so it's phosphoric acid. You only add the hydro when it's a binary acid, meaning, just like the binary ionic compounds, a hydrogen and a nonmetal, not hydrogen with a polyatomic ion, just binary, 2 things you could think of. This can apply to sulfate like you see here and many other substances where a hydrogen will take away the charge. Now, if you wanted to see how this would look with an ionic compound, if we had, for example, barium, let's do barium HPO4. So if you saw this, okay, not an acid, this part does not make an acid, this is an ion, and this is the metal. This is your nonmetal ion, so you have an ionic compound with your metal. I know barium is +2. Now, 2 ways that you can look at this. One, you remembered HPO4 is a 2-, or I don't see anything in parentheses or subscripts anywhere. That means it canceled out, so this had to be -2. Because they always have to be enough of each other to make a net 0 charge. So then you just name it. Barium dihydrogen phosphate. Let's try one with a transition metal. Chromium HSO4, 3. Okay, I know this is not an acid, this is an ionic nonmetal compound, and then I have my 3. So I know that the 3 comes from the chromium. So this will be chromium 3 in parentheses, hydrogen sulfate. Sometimes, instead of writing hydrogen sulfate or hydrogen carbonate, because you cannot go further than that, you can also write bisulfate, bicarbonate. The reason that's not for the phosphates is because you have multiple. Since this is a 2- charge in the bases, adding the 1 hydrogen is the only way that you can still have an ion. Adding more than 1, you have an acid.